So today, the last little section that's in this chemistry unit is on acids and bases, a little bit of kind of a review, a little bit of an oral review of what we did up to this point. At the very beginning, we talked about atoms, their protons, neutrons, and electrons. We talked about how those atoms can lose their electrons, metals losing their outer electrons to become positive ions, and nonmetals gaining their electrons to become negative ions. We then talked about how we can put those atoms together to form compounds. When we put a nonmetal together with when we put a metal together with a nonmetal, we get that trading of electrons and it forms an ionic compound, all right? Ionic compounds have those ions, those charges locked into place when they're solids, so they don't conduct electricity very well when they're solids. But when we dissolve them in water, those ions, those charges are able to move freely, and therefore they do conduct electricity when they're dissolved in water. They have a very high melting point because that structure of repeating ions is very strong, like a scaffolding, and those are essentially the properties of ionic compounds. We then talked about what happens when we put some nonmetals together, things like maybe hydrogen and oxygen, to make what we call a molecule or a molecular substance. Remember, we say that the that the electrons are being shared in a single covalent bond, all right? So molecules, when we test their conductivity as a solid, they don't conduct because all of those electrons, all of those charges are locked into place. Even when we dissolve something like sugar and we check it with a conductivity meter, it doesn't conduct either because, again, all the electrons are locked into place. When we melt things like sugar or wax, they melt at very low temperatures. We don't need a Bunsen burner to melt those. We can easily melt them on a hot plate, so they have low melting points. All right, so that kind of brings us to the end. Oh, we've talked about how to name those things, right? Naming ionic compounds and naming covalent compounds. So that brings us to one last little part of this this unit, and that is on acids and bases. And acids and bases, they are examples of ionic and molecular substances, but they're important because of their properties, all right? Historically speaking, acids and bases have been used in industry and in household products for many years because they have very specific properties that allow them to do very specific things. Okay, so let's talk a little bit about what makes an acid and what makes a base, and then we will get to our activity that talks about the properties of them. You're sleeping earlier than normal, Lexi. We're about 2 minutes into the lecture, and you're already nodding off. You returned very late last night, didn't you? Then I won't pick on you. You did remember your combination, though, this morning, didn't you? Yeah, good. All right, so an acid are chemicals that release hydrogen ions, H+, when they dissolve in water. Now, acids are a special case. If we take a look at this example of this acid here, and by the way, this is called hydrogen chloride, which isn't surprising. I think you could have probably figured that out. It's also called hydrochloric acid. It's got two names, and I'll tell you how we get those names in a moment. This is technically a molecule. It's made up of a nonmetal, hydrogen. Even though hydrogen is on the left side here, it's made up of a nonmetal, hydrogen, and a nonmetal, chlorine. And it's technically a molecule, but it's a special molecule in that when we dissolve it in water, the hydrogen behaves as if it's in group 1, and it creates an ion. So this H falls off. Oops, Yep. Oh, did I not orient the board? Did I not do that as I was talking? That's horrendous. Let's do that for a moment. Can't I? Oh, now I'm panicking because it's not working for me. What's happening here? Click. Click, click. Escape. Discard. Click. Click. Thought I had done this as I was talking away. All right. Now we'll be in business here. Click. Acids and bases. Start. Okay. Now we should be in business here. So this is a special case. This H will fall off and produce an H plus. All right. And we will be left with a Cl minus, a chloride. All right. It is the fact that this molecule starts with an H that makes it an acid. That's how you're going to tell when looking at the chemical formula of an acid. It starts with an H, and that H will then be able to fall off. This will be conductive because those charges will be in the water and they'll be able to move around. All right? Let's talk about just some common, my technology is failing me. It's causing me great pain. Let's just talk about some common acids. Are there any acids maybe that you know of, that you encounter in everyday life, that you are pretty sure that is an acid? Let's maybe discuss that a little bit. It's the Monday after March break, so I'm asking you a question. I know this is probably one of the more painful things that you're going to do in the day. Period one, teacher asking you a question. Acids. Yep. I need more detail on that.
Like the acid that goes in the building, you just put it in your on the barrel.
Is it a liquid?
Yeah.
And it sprays on the bale?
Yeah, and it's called acid.
And it's just called acid. To be honest, I don't doubt that it is an acid, but I have no idea what type of acid they use for that. But that I don't doubt that that is a use, but I don't know the type of acid that is. I would have to do some research. Yep. Yeah, battery acid is phosphoric acid. So if I were to just put here, it doesn't really have a common name, but that's phosphoric acid. And why can't I write on my thing here? Phosphoric acid is battery acid, H3PO4. Again, starts with H, all right? Common name, it doesn't really have a common name, but it is used in batteries. Battery acid, that's a good one. And we're talking about car batteries. We're not talking about little batteries, right? Have you ever come across the little batteries? Maybe you left them in a toy for too long and they got that goop that's coming out of the batteries. That's technically not acid. That's actually a base. Little batteries are what we call alkaline batteries, which means they have a base in them instead of an acid. But car batteries, phosphoric acid. Any others that maybe you know? Yep. Vinegar. Awesome. Vinegar. I have to say Vinegar or I spell it wrong. Vinegar, common name, acetic acid. I write the formula as CH3COOH, all right? And in this case, it's this H that's the one that falls off. It's an end H. It's got a slightly different formula as well that I don't have memorized, and we'll talk about that in a moment. Yeah, vinegar, excellent. It's a weak acid, which is why we can ingest it and not like have our insides completely, liquefied by the acid. What are you going to give me, Sean? Orange juice. All right, citric acid. I like it. I'm not going to put that one on there for two reasons. Not because you suggested it, Sean. Citric acid is a good one, all right? It's also found in all citrus fruits and in apples, et cetera, et cetera. It's what we would call a biological acid. So it has a really large molecule. It's got a really big formula. To be honest, I don't know what the formula of citric acid is. What am I going to? What was I going to say about citric acid? Does it have a common name? It really doesn't have a common name. There's another one that's associated with citrus fruit that is different than that. What's that? And lemons. Yeah, that's good. Lemon is a citrus fruit. Good job. We're really rolling here after March break. The other acid that's involved in those is called ascorbic acid. All right. Again, a big molecular acid. I don't know the formula for it. It's also known as vitamin C. All right. Vitamin C. All right. One other acid that I am going to put down that you may have encountered. If you have, say, a swimming pool and you're opening up the swimming pool and the person comes in and checks the pH and notices that it's not acidic enough, they'll often take some acid called muriatic acid and they'll pour it into the pool to change the pH. So muriatic acid, again, that's the common name. That's hydrochloric acid, and that's HCl, and that's the one that we saw up there. I'm suspecting that the acid that's going on the hay bales is also muriatic acid. That would be my guess, all right, because it's very cheap. It's very easy to make. I don't know what acidic properties the hay has that need the acid. I do know that farmers will use things like muriatic acid as a cleaning product to maybe clean out pipes for like milking parlors, et cetera, So muriatic acid is a pretty common one. Okay, let's talk about the chemical formulas of these acids. And there are two groups of acids. And don't feel you have to make a chart out of this. This is just the easiest way for me on the computer to make a list of things. And they're all going to line up. So don't feel you've got to make a chart. You just need the formula and the name. So there are two main groups of simple acids. And I'm just talking about the simplest ones. The ones that are often used in industry and in consumer products. Those kind of larger acids, and there's all kinds of different ways to make different chemicals that have these acidic properties. Those have quite complex names, and we're not going to worry about that stuff. So I've already introduced you to hydrogen chloride. All right? Hydrogen chloride is called hydrochloric acid. So you'll notice it starts with hydro, ends in ic, and is an acid. This is hydrogen fluoride, a hydrogen with a fluorine, and the naming system is transferable. What do you think this one is going to be called? Yep. Hydrofluoric acid. Hydrofluoric acid. The reason they're called binary is because they're made of two atoms, hydrogen and some nonmetal. Next one. What do you think? Yep, Sean? Hydroiodic acid. Hydroiodic acid. That's a funny sounding word, isn't it, Logan? Hydroiodic acid. That's what you were texting to your friend, right? You just learned a funny word for the day? Yes. Yes. All right. Stop that. You can do that later after class. Logan, what's the name of this next one? It's bromine. Hydrobromic acid. Bromic acid. And H2S is actually, it's the same naming system, but it's got a little extra syllable in it. We don't say hydrosulfic. What do you think we say? Yep. Hydrosulfuric acid. Yep. So again, those are the binary acids. They all start with hydro, end in ic, and because they're acids, we say that they're an acid. There is a second family of acids that's on the next slide, and they're called our oxyacids, and they come from our polyatomic ions list. So we had this list of polyatomic ions that end in 8. We can also add H's to those and turn them into acids, all right? You can imagine we've simply added an H to all of these -1 ions to make them an acid. We're going to do the same with the oxyacids, and again, let me know if I'm going too fast. Again, don't worry about writing the chart necessarily. The lines aren't important here. So I'm doing two things with this chart. Number one, I'm reminding you of the polyatomic ions. All right, they're going to come important when we do our test at the end of the week. Oh, that reminds me, we have some quiz writers that have to write quizzes, and we will do that tomorrow. We'll do that tomorrow. Everybody's getting a bonus one on that. Because, what's that? It's about types of chemical reactions. It's about balancing, word equations, chemical equations. All right? And those of you know who you are, I'm assuming, right? Goodness, that's exciting. We can't remember whether we've written it or not. No, we did write the quiz on the movie day. I'm seeing Elijah, Amanda, Lexi, Keegan, Thomas, Sean, and Adam. All right, that'll happen tomorrow. Because I want you guys to do the activity. Tomorrow's going to be just lessons. I'll make videos. You can write it during that. Then you can watch the videos, get yourself caught up. You will, if everyone is here to write the quiz. Okay, so listen up. This is reminding us of two things. It's reminding us of the polyatomic ions that we find on our chart. And the reason I was reminded of the quiz is because many of us who are not necessarily practicing some of our stuff are struggling with these polyatomic ions. We need to make sure we know where to find them so we can name them. A sulfate is SO4 2-. An H has a +1 charge. In order to turn this into an acid, I need to add enough H's to cancel out this -2 charge. How many H's am I going to put on a sulfate to turn it into an acid? I will say it one more time, maybe a little slower this time. The H has a +1 charge. H +1. The sulfate has a -2 charge. I need to add enough H's to cancel out that charge. What do you think? So this is going to be H2SO4. I'm beginning to think it wasn't the way I asked the question. It was just you guys were way too lazy to put up your hands. And since I was embarrassing you with slow talk, you finally put up your hands. The oxyacids actually have simpler names. This is simply called sulfuric acid. It doesn't have the hydro on the front. So it doesn't have the hydro on the front. It's a simpler name. Phosphate. How many H's on the acid? Thomas? 3. H3, PO4. Any ideas on the name? Doesn't have a hydro on the front. Yep. Phosphoric acid. That's the one that I actually just wrote moments ago on the examples. Phosphoric acid. Chlorate. That's just a -1. We don't put the 1. What's the formula of the acid going to be? What's the formula of the acid going to be? Sorry? That's a 1, -1. What are you looking at? Sorry? In the middle. Oh. No, that's not a 1 in the middle. That's an L. Formula for the acid. Ashley, what do you think? Very good. ClO3. Correct. Now this naming is a little different. Sulfuric, phosphoric, but we don't say chlorinic, even though we've got a little extra on this. What do you think it's called? Yep. Chloric. Chloric. The person who created this note put these two up here because their naming is slightly different. Sulfuric, phosphoric, but this is just chloric. The rest of them follow the trend. That they're simpler. Formula for the next one. What do you think? Formula for the next one. Adam, what do you think? Looking for trends over there? What do we see? H2, CO3, and what do you think the name is? And it's not following these two, it's now following this guy. So it's not, well, actually, that one does kind of break the rule. What do you think? Anybody? Ideas on it? Yep. Yeah, it's carbonic. Very good. That's another common one I didn't talk about. We would have talked about it when we talked about synthesis and decomposition reactions. Carbonic acid is the acid that's formed when carbon dioxide is dissolved in water in the formation of carbonated water or carbonated beverages. So when you drink a pop, that's the acid that's in there, carbonic acid. Here we have acetate. Now, notice 1, -1 is the charge, H, C2, H3, O2. I've actually already talked about this acid. Changing that 8 to the ic makes it become acetic acid. And I wrote that down in our little list of acids. What's that also known as? I had a different formula though, because that's the other formula is the one I was taught. Yep. Yeah, that's vinegar. That's vinegar. The difference in formulas is that we just kind of squeeze together the atoms there. Okay, one last one. HNO3. What do you think this one's going to be called? Yeah, Sean? Nitric acid. Nitric acid. I don't know of any common uses of nitric acid. It's very It's very commonly used in industry, and it's quite dangerous. We used to have nitric acid in the chemical room over there, and then we were advised to get rid of it. I've been burnt with nitric acid in a university lab, not too bad. Like in my hand, I grabbed something that had some nitric acid on it, some concentrated nitric acid. It reacts very quickly, so it can be dangerous. Okay, bases. We've already encountered bases. The characteristic of a base is that it has hydroxide in it. That's, again, one of our polyatomic ions. So it ends in an OH. Bases are also known as being alkaline. That's another word for it. The reason our first two groups of metals are called alkali and alkaline earth metals is that when they react with water, they will produce bases. So when sodium hydroxide is put in water, and we already know that this takes place for an ionic substance, the sodium is able to go off on its own and the hydroxide is able to go off on its own. And it is this hydroxide that that does the damage in which the base does. All right. If you get burnt by an acid, it's the H+ that's burning your skin. You can be equally burnt by a base. It's the OH that does the damage. Some common bases, and these are hard to come up with. For some reason, acids are more known in society really than the bases. I guess they're very useful, but we don't have a lot of bases that we have common names for that are different. There are some. The one that we had here, NaOH, is sodium hydroxide. They don't have any special name that goes with it. We simply name the positive ion sodium and the negative ion hydroxide. Nothing magical about that. There's no necessarily common name for it. Sodium hydroxide is found in drain cleaner. So if you have a drain clog and you use something like Drano, you pour that in the drain, then you end up with, there's strong sodium hydroxide in there. You know, normally if I'm cleaning the house or cleaning the bathroom, I'm not one to wear rubber gloves because I'm not worried too much about the chemicals. They're not normally that dangerously strong. But if I were to use drain cleaner, I would probably get some rubber gloves on because that sodium hydroxide in there is very strong. Another common one would be milk of magnesia. All right. That's used as an antacid. If you've got an upset stomach, you can take something that's called milk of magnesia, and that has some MgOH2 in it. Again, you can see that it has a hydroxide, and this is magnesium hydroxide. Bases are a little more complex than acids. There are many other bases that we encounter in household products, but the issue is that they don't contain OHs. So when you go to grade 11, I'm going to teach you another theory of bases. I'm not going to write these down, but here's some other examples of bases you can encounter in the house. If you were to dissolve some baking soda in some water, all right, which is sodium bicarbonate, that's a base, even though it doesn't contain hydroxide. So our base theory is a little lacking. We need a little more detail to it. Bleach contains something called sodium hypochlorite, and that also is very basic. That can be dangerously basic if you have concentrated bleach. And again, it doesn't contain a hydroxide in its molecule, but in the end, when you dissolve it in water, a chemical reaction takes place that produces lots of hydroxide. Okay, so naming bases are very simple. We name them just as we would name ionic compounds. And that's going to be our last thing that we're going to write today. Oh, no, I do want to talk about indicators. Yeah, naming bases, you can write that down, and we'll talk about indicators. And then we will get to our properties of acids and bases activity. So I'm not going to put any examples for naming bases. And that's because I just did one. Magnesium hydroxide, sodium hydroxide. Name the front part, name the end part. So the last thing I want to talk about before we get to our activity on properties of acids and bases is something that's called an indicator. Have you heard of indicators before? Indicators? Anybody? No? Don't know whether you've done this in grade 9 or 10. Certain chemicals will have certain colors depending on whether they're in an acid or a base. The common indicator that we use, especially in high school, is something called litmus. You can see litmus paper down here. It's actually in the wrong spot. Again, I didn't make this note. I should read it ahead and adjust it. Litmus is actually a plant. It's not, a plant you'll find in North America. But if you take that plant and you boil it and the liquid comes out, and then you take that liquid and you soak it in paper, then you've got this litmus-soaked paper, and we call it litmus paper. It says here some are natural indicators. Red cabbage will do that. If you boil cabbage, which actually starts out purple, if you've ever seen red cabbage, it's a favorite of the Dutch. My mom used to try to feed it to me all the time. I would resist. If you boil it, it's very purple, and then my mom would put some vinegar with it, and it would turn a red color. So it starts out purple, you put some vinegar with it, it turns red. So depending on whether it's purple or whether it's red can tell you whether it's in an acid or a base. Litmus does the same thing. It's actually a plant. It should be put up here with the natural indicators. All right? Litmus is red. Well, I won't tell you. You're going to discover that in a moment. Red or blue are your two options. Whether it's in an acid or a base, you'll figure that out. Chemists have made many artificial indicators. Here's one called bromethymol blue. All right? It's a liquid. Starts out blue. And in a moment, you're going to put a little bit of bromethymol blue in an acid and in a base, and you're going to discover what those colors are. We'll talk about them tomorrow to finish that off. Okay? We also have something called universal indicator paper. Chemists have taken many different indicators and have mixed them together, made a solution, and then put that onto a piece of paper, which then will have a different color depending on what the pH is, how strong that acid or base is. And so you dip that in and you put it on the chart, and you should be able to figure out how strong the acid or the base is. So in a moment, I'm going to be asking you, and you can close yourself up, and you can now get your equipment out, get your device out, get it opened up on the on the properties of acids and bases, which is on today's thing. Let's move fairly quickly here, folks, because I'm noticing the time is running along. Listen up. And you're going to be getting yourselves a dropper plate like we did the other day when we did our single and double displacement reactions. So the dropper plates are on the left. And you're going to be testing some acids and bases. All of the substances that you're going to test with are found in the middle of the lab benches. All right? They're found in the middle. The acids are on one side and the bases are on the other side. All right? I've got vinegar out there as well, but I'm going to take the vinegar away. We're only going to do 2 acids. You're going to put a few drops into one of the dropper plates. And you're going to go through all of the instructions to test with the various test strips. When you take a piece of litmus paper, it's fairly long. You don't need to necessarily use that just for one thing. You can break it into 3 pieces and dip it in and use this for 3 tests. That conserves some of the paper, all right? You can do the same with the blue litmus paper, and you can do the same with the pH paper, or the universal test paper, all right? So break it in half or break it into little pieces so you can test them. There are the indicators. You just need to put a drop or 2 into each of the stuff. And then you're also going to be testing them up against a couple of other solids. You're going to test the acids and bases with a little piece of magnesium. So just take a little piece of magnesium, put it in the well, put a little bit of acid on it, all right? You don't need a whole pile of it. And you're also going to be testing it with some sodium bicarbonate. And to scoop a small amount of sodium bicarbonate, there are some toothpicks, and you just need a tiny little bit into those things, okay? Ideally, it would be nice if we could finish this within today's lesson, but time's getting tight. We'll see if we can. And again, you can type your answers directly into your phone or your device. You do not need to write it down. So just type what you see in the observations box. We're going to need goggles, and we're going to want to work fairly quickly. Go ahead. Have you accumulated enough charge to succeed? All right, good. Again, ladies and gentlemen, there are white pieces of paper in the middle as well, so that you can put it underneath your dropper plate so you can see some better colors. Please put all of your little used pieces of paper on a paper towel so we can throw them in the garbage when we're done. Let's proceed, guys. Let's get the instructions rolling. This is not necessarily discuss what you did on March break time. When you are finished, you can empty the trays into the waste container, rinse, and turn them upside down on the paper towel to let them dry. What do you need? What do you need, guys? You don't need the lab booklets. You can type it directly into your documents. What do we got here? HCO, hydrochloric acid. That's the stuff. You need to cover your eyes, actually, Bailey, with the goggles so they protect them. If you're waiting for her to be the leader, I don't think it's going to happen right now. Oh, okay. You can start with a base, or you can start with the acid, the other acid. You don't have to do it in order. As long as you follow the instructions for that substance, you just have to put your observations in the appropriate row. Ladies and gentlemen, listen please for a moment. You do not need to all start with hydrochloric acid. If that chemical is not available, you can follow the instructions as you would simply with one of the other chemicals. You will then simply put in your observations for that chemical in the chart. You don't need to do it in the order in which it's stated. So you guys are grabbing, these are bases. So you'll do everything that you're going to say that it's going to instruct you, except you'll put your observation in for that particular base. You see what I mean? So you don't have to go in order. So you've got something in there? Oh, that is true. All right. Well, you can use a different well there. That paper you can put underneath in order to see. There's the little legend right there will tell you. You see what I mean? What I did was I took some out and I laminated them so that you could see what the pH is. How's it going?
She does fifth well. So in 5? Oh.
Well, you've obviously got some in there now.
There's like 3 that you've done. Put it on there.
Oh, that's 5.
Doesn't matter. The number of drops is not important.
No, she wants to know if you put them in multiple. Like, if you put them in 5 things?
You actually don't need 5 separate ones, because when you dip the paper in, you can use those to put the indicator in when you're done looking at the paper. So you probably need about 1, 2, 3. You probably need 4 wells, really. But 5, you can do 5. 5's fine. So here's some legends for the, that's for the pH paper. So you can tell, you can share those around. So you're going to test it with the pH paper, and when you match the color for it, it'll tell you what the pH is. So is that litmus paper or pH paper? That's litmus paper. That's good. You're half asleep and you got that right. Litmus, you're just doing colors. Well, does it change color, or does it stay the same color, or what does it do? And what does it do? So it stays red, just getting wet. That's right. You could say it just got wet, but the color stayed the same. You need to quit with the messages. All right? I could see right over your mouth. There's emojis all over the damn place. Where's your thing to put your observations in? You don't even have it open. So you know, you can have fun if you want in here, but your mark will not indicate so. Then you're gonna be told by your mom to go visit Mr. Sanders at lunch, and I'm gonna say, no, you're on your phone all the time. I'm not visiting at lunch. I work during class. See the difference there? All right.
Yeah, we should cut it. Rib it into like 4 pieces, yeah.
Tiniest little pieces, but you'll be fine. You'll be able to dip those in. It's okay. You put some phenolphthalein in there?
Yeah.
1 drop will do you.
Oh, okay.
Yeah.
Okay.
Yeah, you don't need to load up on phenolphthalein.
Okay.
But that's okay. Yep. Yeah, you put a little dip in it, see what it does. You put a little, yep, put the other one in it. Yep, see what it does. Yes, the indicator needs a drop or 2. You don't need that much. That is for the pH paper, which are those right over there in the little container. So what did you got here? Look, that's exciting. Things are happening, eh? Yep. I want to know what color it changes to. Yeah. Well, what is this? Oh, red.
red litmus.
I'm not sure.
So use that one for the red and blue one.
Sure, you could. All you got to do is dip it in.
Oh,
Yeah, even if it's in there, you can put the other one in there too. So was that a blue one?
that was this one.
Oh, that was this?
Yeah.
So what is the pH then of this?
We said 2.
Beautiful. Awesome. You could dip your litmus in there too.
Did we do that right?
What are you seeing? What did you do?
I don't know.
Well, did you put some? What did you put in?
We put in the
And what did it?
and the hydrogen.
That's fine, as long as you're writing down what you see. Yep.
Red and blue. Do you rate it
So,
red or blue?
what did the
Yes
red
or no?
litmus do?
Oh, so
What did the red litmus do when you put it in? So just dip it into something. Stay the same. So say red. Stays red.
red.
What did the blue litmus do?
Oh, Mark, you have 2
That's okay. It doesn't matter.
Turned red.
Turns red.
Oh, okay.
So red litmus stays red. What are you doing over here? Oh, oh, that's what we're doing. And the blue litmus turns red.
Oh.
No.
Now.
Okay.
So we put the blue in the same one.
Yeah.
Oh, it turns red.
So the red litmus stays red, and the blue litmus turns red. So litmus is red. Beautiful. Computer or Chromebook? So it's a full-on laptop. It's not a Chromebook. Cool. We've got a test. Which test are you doing? Which paper are you using? We've got 3 different types of paper. So which substance do you want to test? Have you tested them yet?
The hydrofluoric acid.
And what did it say?
Yeah, it's red.
And what's the pH then?
1.
Okay, so you wrote down a pH of 1. Nice. Beautiful. You've done it. You've done that test.
Yeah, you put it blue. Yeah, it went red. So wait, what does it mean by mixed with magnesium?
Yeah, so you're going to put a little magnesium with the acid or the base or whatever you're testing.
Okay.
And you're going to see what it does.
So it just goes with
If you don't see, did you put some magnesium in one? And what did it do? Phenolphthalein stays colorless. No, you can put the metal in one of them even with the papers if you wanted to. If you wanted to scoop the papers out with a toothpick, you could get them out of the way.
These other acids and bases.
Have you done all the tests?
No.
We'll do all the tests for the first one.
Oh, we need that blue. Do we use?
What paper is that? And which are you testing? What acid or base are you testing? And did you use the pH paper?
Yeah. But
So then why would you use it again on that same stuff?
no. What's the blue thing?
That's blue litmus paper. There's instructions here that'll tell you exactly what to do,
Oh,
step by step. It's an amazing thing.
turns yellow.
The brome thymol blue turns yellow. Sodium bicarbonate, and it's the powder. The sodium bicarbonate is this. So take a scoop with a little toothpick and put it in one of them and see if it does anything. Now, are you doing a base? Did you put the metal? Are you doing an acid or a base? Okay. Keep rolling. You're doing fine. You don't need to dump a lot in there, Garrett. Well, you could just put it. That's fine. You just put it on the edge, though. You know what I mean? A little bit on the scoop itself would be enough. That's okay. Is that exciting? No. Because no. Friday. You'll write it when you get back. That's not a big deal. You just write it when you get back. When do you guys leave? Sorry? So tomorrow is going to be the end of our lessons. You'll have all the information you'll need for the tests. The only thing will be that lab that we do on the Wednesday, and I'll think about what we'll do for that.
Is this dissolving? What would you write?
Let's just say it's not dissolving. You don't know whether it's dissolving or not. Is it producing a bubble? Is it producing bubbles? That's all you need to write, that it's producing bubbles.
Bicarbonate.
That's enough. Good. You just need a few bubbles.
I know what
We don't need all the bubbles in the world.
Can I just write bubbles, or do you want me to write?
No, produces a gas. That's good. Yep.
Is it producing gas?
Bubbles are not a gas.
Yeah.
Yes, it is producing a gas.
So I write. You can't see that though.
Yes, you can. Bubbles is a gas. When we see bubbles, we can assume that a gas is being produced. We can actually test that gas.
Would we say that?
Right here, watch this. Yeah, let's watch this. Let's see what this does. What did it do with the?
Nothing.
It went out. That's carbon dioxide gas on this one. Where's your magnesium? Did it all bubble up? See, we could test its gas as well, but I don't know whether it'll work very well on this one. If I were to catch some of this gas, I don't know if we'll get a test. No, that's hydrogen gas. It's supposed to burn. Just produces a gas. It's good enough. Quit taking lab selfies and let's do lab reports.
I'm done right now.
Did you do all of it?
No, I just seen in our thing.
So you're going to do a selfie.
Yeah.
Here, go to the bottom. Look, you could answer the question. What are the properties of acids and I'm hoping you found that all of them behave the same way. That's good.
Oh wait. Yeah.
The acids. Because I was burning a toothpick to test the gas. They both produce a gas.
You just write producing gas.
Yes, you can just say it produces a gas. Phenolphthalein is how you pronounce that. Phenolphthalein. Where's the lid? Oh, there was no lid on that phenolphthalein, correct? So it couldn't have a lid. Phenolphthalein. It's got a PHTH.
How about 2.8?
pH 3, I'm concerned about that.
Right here because it's brown.
Look at, I'd say it's closer to 12
Okay.
or 13.
Okay. Yeah.
Yeah. Yep.
Sodium hydroxide.
It,
Hydroxide. The other one.
again, it doesn't matter which one you do first. You're going to do the same tests anyway. Have we got our tests figured out yet, ladies? I'm thinking you guys pairing up as a team, maybe not a...
Bro, what did I do?
Okay. All right. So what happened was there's already a little bit of the indicator from this one in here, and that's the phenolphthalein. So don't worry, that's the phenolphthalein.
Is that, are you sure?
Yep.
Is that when the other ones were clear?
Is this phenolphthalein here
Yeah.
in these?
Yeah.
Somebody didn't clean theirs out, and there was already phenolphthalein in there. See, watch. If I take some of the base and I neutralize the acid, see how it's turning purple? All right. And if I put enough into it, then it's going to be full. I'm hoping I could get it to stay purple. I can't. The acid's stronger than the base. But there's probably some phenolphthalein in there. Don't worry about it. You can still test with it. You can still put a piece of pH paper in it or whatever. Are these real gasps of scientific discovery, or are they fake gasps of scientific discovery? It's, don't write down pretty color,
I
please.
put dark pink.
Oh, dark pink is fine. I've heard some people describe it as fuchsia, but I don't know what fuchsia is.
I don't think guys know different tones of colors.
No, that's correct.
Same Sam. It's always like
All right, I've distracted you. Stay with your dark pink or whatever you said.
Oh, that one's blue. Yeah.
I'm hoping we're noticing that the acids behave the same way and the bases behave the same way. Are we noticing that? Are we learning that?
Yeah.
All right, that's good. Ladies and gentlemen, keep in mind, sometimes no reaction or no observable reaction is valid. So sometimes when you see something, nothing exciting happen, that's what you're writing down. That's what you're seeing. Yep. Ah, that's exciting. So as it's wicking up the top, all right, it's probably some of the water is evaporating. It's probably changing the concentration of that. Is this a base? So it's probably changing the concentration. So it's actually making it maybe a little less strong than it is down in the bottom. So it's simply indicating that the pH is a little different right there on the leading trail of that liquid as it wicks up it. You want to read what it looks like down in the bottom.
Mr. Sanders, which one would we fall?
What are you debating between? It makes no difference for this experiment. It makes no difference. It's really high, right? That's all that matters. So whatever you guys think it is what it is.
I know, but don't we need that much?
Yes. Again, that's up to you guys. What are you debating between?
11, 12, and 10.
So, in this case, it's not important. So it's what you feel it is. I would likely use the color that's in the liquid, not what's traveled up the side of the paper. You know what I mean? Because as the liquid wicks up that paper, things are happening, the air is attacking it, it's doing all kinds of stuff. We want what's happening in the liquid, okay?
My nose is like,
Are we learning things here? Are we gaining information as we go? All right.
where's the ammonium?
I'm hoping we're finding that the properties are similar. Are we finding the properties are similar between acids and bases, for acids and bases? Well, it's going to do what it's going to do. I can't change the laws of physics. That's litmus paper. This is not for litmus paper. This is for pH paper. That's fine. So if you saw it turn blue, say it turned blue. Which one are you guys on here? You're on getting down to the last one? Sodium hydroxide? Right, gotcha. No, I'm just checking the time. It's looking good. You guys have worked well here. The clock's on my desk. We're at about quarter after. That's because I want to wait for the bell so I can set it to the bell. Okay, so as the base wicks kind of up the side, put it into the liquid and leave it in the liquid, and determine the color of what's in the bottom there, because as it goes up the paper, it's reacting with the air, and that's changing things. We want what's in the solution. Yeah, there must have been some periodic motion or something. So you are, why aren't you typing?
My new class won't work. I can't log in.
You have a login issue? Well, that needs to be fixed.
No, like, I got my password. I won't let me get on it. It says error.
Oh, you're one of those people. I'll just do it at home.
I can't do that.
So you got a tattoo on vacation, did you?
What would you like us to put the, what would you like us
Oh,
to do with the...
is everything done?
plastic?
You're gonna rinse them. You're gonna dump it into the waste, rinse it, and just put it on a piece of paper towel over there. All the little pieces of paper you can put in the garbage. All right? Ladies and gentlemen, when you are finished, please don't put the little pieces of paper in the sink because they don't dissolve. All right? And you can't take your goggles off until you're done cleaning up and you're going to sit at your seat. You can put it in the waste container. If you can dump it in the waste container, that's great. If they end up in the sink, I want you to kind of grab them and put them in the waste container. Are you finished? What is your issue? You're not... You're the most fragile human being in the entire history of human beings. You should just go straight to crutches or a wheelchair right now. Just give up this locomotion part, and yeah, that's or do like Sheldon did. You can get a computer. You can stay at home in bed, so you don't hurt any muscles. Okay. Are we almost finished? Despite your lethargic demeanor today?
Sunday night?
Mm-hmm. Sunday, that's yesterday.
Yeah. No, like Sunday morning, early in the morning. I have to get up for 2 a.m. Actually, airport from Bottom. And then I was like traveling all day. We had to drive from Toronto.
Yep. And that's that. And that's a March break. Again, please keep your goggles on as you're cleaning up so you don't get flashes of things in your eyes. So, Natalie, you can leave your partner to clean up because you don't have goggles on. If you just dump it in there, hopefully they come out. All right. All right. Phenolphthalein. Phenolphthalein. Silliness. There are 2 questions to be answered at the bottom of that document. It's simply you stating what those properties were. The other document is just a practice sheet on names and formulas of acids. You don't have to hand that in. That's just for practice. Are we going to make it here, gentlemen? Let's put used things in the garbage, please. You're going to sit right here quietly as your friends answer the 2 questions and complete it and turn it in during class. If you could do it now, you might as well. Just type it up in 2 minutes and hand it in. So don't bother your friends as they get their homework done, and then they don't have to do that at home.
When it means what 2 properties, like a color change, is that?
So what properties were common for both the hydrochloric acid? So what do you mean 2 properties?
Like, don't have to be like the same.
Yes, so what was common for sulfuric acid and hydrochloric acid?
A lot.
I want you to state all those common things, because that's what's common about all acids. So just state the pH was this for the acids.
For the acid.
Sure, for the acids.
I don't have to like name them.
No. What was the question back there? I'll talk about that tomorrow. No, it's not true. Coming to class saying, I can't remember my combination is a dumb something. I don't know if that's a question. That's an issue maybe. But the other document that's on Google Classroom for this day is just a practice sheet on names and formulas for acids and bases. That does not need to be turned in. All right, that does not need to be turned in. Yep,
Okay.
they are bases. Do they end in hydroxide?
Yeah.
That's what makes them bases. You're down to about 5 minutes there, guys, so hopefully you can get that finished up and tidied up. So you just restate what all those properties were.
Right.
Nothing. Better to have it as colorless. Yeah, colorless would be better. I don't know if you can fix that up or not. You can write HCl, sure. As what, a name for hydro?
What was the white powder called?
Oh, sodium bicarbonate, and that's NaHCO3. sodium, and that's a bicarbonate. Sodium bicarbonate. You're welcome. There still exists a lab that you missed.
I know.
I'm going to just leave it as blanks, but I still want you to get that completed at some time.
Okay.
So it won't be as zeros. Say I get to the thing next week, and I got to do a report. I'll leave them as blanks. But if, let's say, by the end of the course you still haven't completed that, I will turn those into zeros. Does it make sense?
Yeah.
Get observations from somebody and then just complete it. Okay? Yeah, you can leave it right there. That's fine. I gotta tidy it up anyway, and it's some chaos on the other tables anyway. That's fine. Yeah, the clock isn't there because I'm waiting for the bell to go, and then I'll start the clock at exactly 9:30. I've got 9:25. 28. They have to reset the bells, so I don't know where the bells are going to end up, because the bells are like resetting a clock as well. I want my clock to be on the bell. That's what I'm trying to get. So as I stated, folks, listen up. Listen up. All you got to do is answer those two questions talking about what the common properties for acids and bases are. Then you can turn that in and be done. All right? Listen, please. Listen, please. The second sheet that's on today's entry is simply a practice sheet. All right? It is simply a practice sheet for names and formulas. If you turn in your lab report, you won't be able to type in your answers on that practice sheet, because what happens is it locks both of them out till I return it to you. So if you want to do the practice sheet, you'd have to do it on a piece of paper if you've turned in your lab report, because what will happen is it'll turn in both, lock them out. In other words, I'll have control as I mark, and then when I return, you get control back. So you can do that sheet just on a piece of paper as practice. Have a seat, folks. Have a seat. Oh, one last thing. Just a reminder, those of you who still haven't finished the single and double displacement labs, you got till tonight. I'm not taking any late marks off. You've got to tonight to finish that off and turn that in. Okay? All right? I have it at tomorrow night, but it would be nice. Well, if you're done, you can turn it in. That's great. Okay, that's officially 9:30. My clock is running, and we'll see you tomorrow. We'll see you tomorrow. And we're back in business, like we never missed a step. Awesome. That is, that's some back in business? Do they have a song that's back in business? Taking care of business. Yes.